Hi everyone, my name is June and welcome to Smart Alex Mathematics. In our last video, I went through the theory of when we need to reverse the sign when solving linear inequalities. What I'm going to do in this video is to work with you through lots and lots of worked examples so we can apply the concepts we've learned, and hopefully that will help you be able to understand the questions and be able to do the questions yourself. Let's get started. First, we're going to start off with one-step linear inequality. The first question I have here is x minus 5 is greater than 2. Like solving a linear equation, what we're going to do is we're going to add 5 to both the left and the right-hand side. Minus 5 and plus 5, these will cancel out. So on the left, we're going to have x, and on the right, we're going to have 7. But remember, the operation of addition does not reverse the inequality sign. So our solution would be x is greater than 7. And if we want to represent this on the number line, we're going to have an open circle at 7 because x is greater than 7 means we do not include 7. And we're going to draw an arrow pointing towards the right of the number line to indicate that our solution contains values that are greater than 7. For the second question, we've got 2 plus x is less than or equal to negative 3. Same process. First, we're going to subtract 2 from both sides. That's going to get rid of the 2. We're now going to have left x on the left-hand side. And on the right-hand side, we're going to have negative 5. But because subtraction does not reverse the inequality sign, our solution will stay as x is less than or equal to negative 5. To represent this on the number line, this time we're going to have a closed circle at negative 5. For values less than negative 5, we're going to have the arrow pointing towards the left. The next question, I have x divided by 3 is greater than or equal to negative 2. What we're going to do here is we're going to multiply both sides by a positive 3. That's going to get rid of the 3 on the denominator, leaving me with x on the left-hand side, and on the right-hand side is negative 6. But remember, we do not reverse the inequality sign when we multiply by a positive number. So the answer will still be x is greater than or equal to negative 6. This time we draw a closed circle at negative 6, and the arrow will be pointing towards the right. The next question, 9x is greater than 45. This time we're going to divide both sides by a positive 9. Recall that whilst this gets rid of the 9 on the left-hand side, the inequality sign does not change because we are dividing by a positive number. Our solution then becomes x is greater than 5. So this time we're going to have an open circle at 5, and the arrow is still going to be pointing towards the right. Let's now look at some two-step linear inequalities. The first, I've got 2x plus 3 is less than or equal to negative 5. Here, we're first going to subtract 3 from both sides. This step does not reverse the inequality sign. We have on the left 2x and on the right is negative 8. The sign remains in the same direction. Next step, we're going to divide both sides by a positive 2. Again, this does not reverse the inequality sign, so our final solution is simply x is less than or equal to negative 4. The next one, we've got 4x divided by 3 is greater than 6. The first step, we're going to multiply both sides by a positive 3. That gets rid of the denominator. We have 4x is greater than 18. Remember that we do not reverse the sign again in this case because we're multiplying by a positive number. We then divide both sides by a positive 4. This does not reverse the sign, so the answer is x is greater than 18 over 4, or simply 9 over 2, or just 4.5. So far, we've only looked at questions where we didn't need to reverse the inequality sign because we simply added, subtracted, or multiplied or divided by a positive number. What we're going to look at now are questions where we do have to consider the reverse of the sign. The first question on the left-hand side, I have x divided by 2 is greater than negative 8. In order to get rid of the 2 on the denominator, we're going to multiply both sides by a positive 2. Now multiplying by a positive number does not reverse the sign, so our answer simply becomes x is greater than negative 16. Let's look at the one on the right hand side. This time I have a negative x divided by 2 is greater than negative 8. In order to get rid of the negative sign on the left, we're going to multiply both sides by a negative 2 because a negative multiplied by a negative is going to give us a positive. That's going to get rid of the 2 on the denominator as well as the negative sign. On the left, we now have a positive x, and on the right, we have 16. But because we multiply by a negative number, this time the inequality sign is going to change direction, and our answer becomes x is less than 16. The next one, I've got two-step inequalities. 1 minus 3x is greater than or equal to 7. First step, we're going to subtract 1 from both sides. That does not reverse the sign because we're simply doing the subtraction. We have negative 3x on the left. On the right, we have 6, and the sign is still the same direction. The next step, I want to get rid of the negative 3. So we're going to divide both sides by a negative 3. This time we're dividing by a negative number. So we have x is less than or equal to negative 2. Notice the sign reversal. The next question, minus 2x plus 4 is less than negative 6. First, we're going to subtract 4 from both sides. That doesn't reverse the sign. We have negative 2x is less than negative 10. But in our next step, we need to get rid of the negative 2. So we're going to divide both sides by negative 2. That's going to give us a positive x on the left. On the right is 5, but this time the sign will reverse. So our answer becomes x is greater than 5. For this next question, I want to show you two ways of doing it. When we have variables on different sides of the inequality, what we want to do is we want to move the variable to the one side. We can either move the left to the right or the right to the left. So for the first one, I'm going to subtract 3x from both sides first. Now that's going to get rid of the 3x on the right. We now have 30 minus 8x on the left is less than or equal to negative 2. The sign does not reverse because we simply did subtraction. Next step, I'm going to subtract 30 from both sides. Subtraction doesn't reverse the sign. So we have minus 8x is less than or equal to negative 32. In our next step, we want to get rid of the negative 8. So this time we're going to divide by a negative 8, which is a negative number. And this means that we're going to have to reverse the inequality sign. So our answer becomes x is greater than or equal to 4. Now doing the same question on the right hand side, instead of moving the 3x to the left, this time I'm going to move the 5x to the right. We're going to add 5x to both sides. That's going to get rid of the negative 5x on the left. We have 30 is less than or equal to 8x minus 2. So notice here that my sign doesn't change. The next step, we're going to add 2 to both sides. The negative 2 will cancel out. We have 32 is less than or equal to 8x. And this time, to get rid of the 8, we're just going to divide both sides by a positive 8. So the sign does not change. We have 4 is less than or equal to x. Another word, this is the same as saying x is greater than or equal to 4. And what we see here is that both sides will give us the same answer. The next question, we now work with some brackets. First step, we're going to expand the bracket first. So we're going to multiply 3 to both terms inside the bracket. This is going to give us 6x minus 3 is greater than 12. Expanding the bracket does not reverse the inequality sign. We now have 6x minus 3 is greater than 12, and we can proceed solving it normally. So add 3 to both sides. That doesn't reverse the sign. We have 6x is greater than 15. We then divide both sides by 6. Again, that doesn't reverse the sign. We have x is greater than 15 over 6. Another word, 5 on 2, which is the same as 2.5. So our final answer is x is greater than 2.5. Now on to our last question. This time I made it slightly more complicated because we have brackets on both the left and the right hand side, as well as variables on both sides. First step, we're going to expand the bracket on both the left and the right hand side. This is going to give us 6 minus 2x minus 4x is greater than or equal to 8x plus 40 minus 6. The next step, we're going to simplify both the left and the right hand side. The minus 2x and the minus 4x are like terms, so this simplifies to 6 minus 6x is greater than or equal to 8x plus 34. We now have the x on the left and the right, so we're going to bring the x term across to the same side, subtracting 8x from both sides. Again, this doesn't reverse the inequality sign. We have 6 minus 14x is greater than or equal to 34. The next step, we subtract 6 from both sides. This does not reverse the inequality sign. With minus 14x is greater than or equal to 28. But in our last step here, we need to divide both sides by a negative number, negative 14. And what's going to happen is our sign will reverse and the final answer is x is less than or equal to negative 2. Thank you so much everyone for watching this video. We worked through lots and lots of examples, so I do hope that you did find it helpful. If you did, please help us by clicking like, share and subscribe. We'll certainly be making more of these maths videos, so I'll see you all in the next one. Bye for now.